Good morning, Mr. Jones! Thank you so much for coming out today to watch the Daily Precipitate. It's going to be a blast, let me tell you. And I'm just so excited to share our new findings with the scientific community and smart people like yourself. You well know, we have had our scientists searching the world for new ways to create a precipitate reaction. And so far, we've had little luck. But I just got a call from my good scientific colleague, Hayden Hubbard, and she has an amazing discovery to share with us. But first, we need to define what a precipitation reaction is. Precipitation reactions are a subclass of exchange reactions that occur between ionic compounds when one of the products is insoluble. A precipitation reaction can occur when two solutions containing different salts are mixed in a cation/anion pair. The resulting combined solutions forms an insoluble salt. This salt then precipitates out of the solution. Wow, that was really informative. Now we know what a precipitation reaction is. And I think it's about time that we got Hayden on the phone and asked her to tell us what she found today. Hayden, it's all yours.
Thank you, Rosemary. Now moving on to our equation. When balanced, the reactants of the equation read as 2Na3PO4 plus 3CaCl2. The product of this balanced equation reads as Ca3PO42 plus 6NaCl. The parts of this equation which are soluble would be the parts that are aqueous. These said parts in this equation would be the 2Na3PO4 and the 3CaCl2 and also the 6NaCl. The only part of this equation that is not soluble or aqueous would be the Ca3PO42, which is a solid.
Wow, Hayden, thanks a lot for that. I can't tell you how much the scientific community appreciates your finding for the precipitation reaction for calcium phosphate. It truly is an amazing reaction. Now, I think that we should talk more in depth about how to make the ionic equations and the net ionic equation for this reaction. They're actually quite interesting, and we'd love to talk about them with our viewers. Alright, here you go. Here you can see the ionic equation for this precipitation reaction. As I'm sure you can tell, calcium phosphate, which is the precipitate, has not been broken up into its ionic compounds. This is because it is a solid and it is the precipitate of this reaction, so it cannot be broken up. The rest of the reaction can be because all of the compounds are aqueous and have not precipitated in the reaction. This is the net ionic equation. It is called the net ionic equation because it only includes the compounds necessary to create the precipitate. In this situation, the compounds necessary are 3Ca2+, which is aqueous, plus 2PO4 3-, which is also aqueous. These two combine to create Ca3PO42, which is a solid, and is also the precipitate of the reaction. Alright, Hayden, I think it's about time you showed them the video of the actual reaction. Our viewers are dying to see it.
In this video that you will see, Na3PO4 will react with CaCl2. How this reaction will go down is this chemist will measure out the amount of the substance that he needs, and then he will mix them together, stirring them to ensure that the reaction occurs. He can tell that the reaction has occurred once he sees that there is a solid in a once aqueous solution. This solid would be the Ca3PO42 as seen in the equation.
Wow, that was a really cool video. Well, it seems like that is the end of this day's newscast, and I hope we can see you again sometime soon at the Daily Precipitate, every Friday from 9 p.m. to 10 p.m. Thank you.